Hi, my name is Hansi Disanayak, and today I'll be introducing a powerful and transformative technology, which is blockchain. Blockchain is essentially a distributed and decentralized digital ledger. This means that instead of relying on a central authority to manage data, it allows multiple participants to securely share and verify information. It was first introduced in 2008 by Satoshi Nakamoto as a backbone of the cryptocurrency Bitcoin. However, its use has expanded well beyond cryptocurrency. Today, blockchain is applied in healthcare, finance, supply chains, and even government services, offering solutions where transparency, security, and trust are crucial. At its core, blockchain ensures data integrity through cryptographic hashing and concession mechanisms, making it nearly impossible to tamper with recorded data. In the rest of this presentation, I will walk you through how it works, its benefits, and some of the key challenges to watch out for. Let's begin by understanding how works and what makes it so transformative. Let's now take a closer look at how blockchain actually works. At the heart of blockchain is a chain of blocks where each block contains transaction data, a timestamp, and cryptographic hash linking it to the previous block. This creates a tamper-proof of structure where any change in one block would be break the entire chain, making the system highly secure. Unlike traditional databases, blockchain operates in a decentralized network. This means there's no single server authority. Instead, all participants or nodes have a copy of the entire blockchain and validate transactions together. This is made possible through consensus mechanisms like proof of work or proof of stake, which ensures that everyone is in the network agrees before new block is added. This structure allows blockchain to be transparent, resilient, and resistant to fraud, which is why it's gaining traction across so many industries. Now let's talk about one of the most important aspects of blockchain, consensus mechanism. In any decentralized network, you need a way for a participant to agree on which transactions are valid. This is where consensus algorithms come in. The first and most well-known is proof of work, introduced by Satoshi Nakamoto in blockchain Bitcoin. It's very secure but comes at the cost of high energy consumptions and slower processing speed because minor compared to solve complex mathematical puzzles. Then came proof of stake, which selects validators based on how much cryptocurrency they are willing to stake. It's much more efficient, scalable, and uses significantly less energy, which is why never networks like Ethereum 2.0 are moving in this direction. Finally, private of permissioned blockchains where participants are known. We use PBFT or practical Byzantine fault tolerance. This allows faster consensus with less energy, but it only works well in smaller controlled network like Hyperledger Fabric or Corda. So overall, different consensus methods are used depending on the type of blockchain and the goals of the network, whether it's public, private, secure, or fast. Now let's look at smart contracts and the type of blockchains. Smart contracts are programs stored on a blockchain that automatically execute actions when predefined conditions are met, like releasing a payment once goods are delivered. This removes the need for third-party services like banks or lawyers, reducing both cost and processing time. For example, in Ethereum, smart contracts are written in a language called Solidity and became part of the blockchain once deployed. Once activated, they can't be changed, making them reliable and tamper-proof. Now, moving to the type of blockchains, public blockchains like Bitcoin and Ethereum are open to everyone. Anyone can participate in the network, validate transactions, or build smart contracts. Private blockchains like Hyperledger Fabric are permissioned, controlled by one organization. These are typically used in business environments where privacy and efficiency are important. Then we have consortium blockchains, a hybrid model. They are shared among multiple trusted organizations. A good example is IBM Food Trust, where companies like Walmart and Nestle use blockchains to track food supply chains securely. So, depending on who needs access and how secure or open the system should be, different type of blockchains and smart contracts can be applied. Let's compare blockchain with traditional databases. Both systems are designed to store and manage data, but they differ significantly in their structure, security, and use cases. First, in terms of control and governance, traditional databases are centralized, meaning one organization or server has full control. In contrast, blockchain is decentralized. Data is validated by a network of nodes, not a single authority. When it comes to data modification, traditional databases support full CRUD operations. You can create, read, update, and delete data. However, blockchain data is immutable. Once added, it cannot be changed, which adds a layer of trust and traceability. For performance, database can process thousands of transactions per second, making them ideal for applications like banking systems or real-time analytics. Blockchain, especially public ones, are slower because every node must verify transactions using concession mechanisms. One security and transparency, blockchain uses cryptographic hashes and public ledgers to provide high visibility and resistance of tampering. Traditional databases rely more on firewalls, access roles, and internal controls, which are more vulnerable to incident threats. Blockchain technology offers a range of benefits, especially in context of data management. First, it ensures transparency and trust. All participants in the blockchain network can view transactions, which fosters trust and accountability. Second, data integrity and immutability are key. Once data is recorded on the blockchain, it cannot be changed, which means it's reliable and tamper-proof. This is especially useful in areas like healthcare and financial reporting. Next, blockchain offers enhanced security through cryptographic hashing and decentralized consensus. This makes it resistant to cyber attacks and unauthorized changes. Smart contract automation allows for self-executing agreements that reduce the need for manual inventions. These contracts automatically execute tasks when certain conditions are met, improving efficiency and reducing errors. Finally, blockchain reduces intermediaries by enabling peer-to-peer interactions. It minimizes the need of third-party verification, leading to faster process and cost savings, particularly in industries like cross-border payments and real estate. To conclude, blockchain is fundamentally transforming the way we manage and share data. Its core strengths, decentralization, transparency, and immutability, make it an attractive solution for many industries from finance and healthcare to logistics and government services. However, despite its growing impact, there are still significant challenges to address. These include scalability issues, high energy consumptions in certain consensus models like proof of work, and regulatory uncertainties that vary across countries. Looking ahead, the future of blockchain is promising. We are seeing emerging innovations such as its integration with artificial intelligence and the Internet of Things, which opened doors for smart automation and secure device communication. Technologies like layer 2 scaling solutions are also helping blockchains become faster and more cost efficient. Furthermore, institutional adoption is rising with governments exploring blockchain for public records and central bank digital currencies. Overall, blockchain continues to evolve into a foundational technology, paving the way for a more secure, transparent, and efficient digital future.